Hello, geometry people. We're going to continue our study of trapezoids, and today we're going to look at the isosceles trapezoid. Now, what makes an isosceles trapezoid different from a regular trapezoid? Two things. An isosceles trapezoid has congruent legs. That's what the word isosceles means in Greek. And it has congruent base angles, two pair. A lot like an isosceles triangle, as a matter of fact. So let's draw an isosceles trapezoid. Congruent legs. Those two are equal to each other. Congruent base angles. This angle here is congruent to that angle there. Now, what makes this a little bit different is that a trapezoid, recall, has two bases. The top and bottom are both called bases. So that means these angles are also called base angles, and they're also congruent. So it turns out all you need to know is one angle in an isosceles trapezoid, and you can find the other three. This is an isosceles trapezoid with two congruent legs and two parallel bases. If this angle is 30, then this angle is also 30 because base angles are equal. And then for any trapezoid, angles along the leg are supplementary. So that means this angle is 150 and that angle is 150. The second thing about an isosceles trapezoid is that third thing, forgot to tell you this, let me put it up there. It also has congruent diagonals. So if we draw the diagonals of an isosceles trapezoid, let's call this trapezoid A, B, C, D, and let's make it isosceles. The diagonals are also congruent. AC is congruent to DB. So if AC is equal to 3x plus 12 and DB is equal to 5x minus 2, how do you find x? You set them equal. That's minus 3x. 12 equals 2x minus 2. Add a 2. 14 equals 2x. 7 equals x. Now here's something to think about. What other type of quadrilaterals have congruent diagonals? If you think about the Jamaican flag, hopefully you'll remember a rectangle has congruent diagonals also. What makes the rectangle and the isosceles trapezoid different is that even though they both have congruent diagonals, only in a rectangle do the diagonals bisect each other. In an isosceles trapezoid, the diagonals do not bisect each other. So if I call that point E, AE does not equal EC. They don't bisect each other. Okay? Let's continue looking at this trapezoid right here. If angle DAB is equal to 35, what is angle CBA? Well, DAB is this angle right here. CBA is that angle right there. They are base angles. They are congruent. What is angle ADC? ADC is that angle right there, ADC. That angle is going to be supplementary to the angle that measures 35. So what's 180 minus 35? 145. And you can maybe guess what the last angle I'm going to ask you, DCB. DCB is right here, and the two top base angles are also equal, 145. Let's do one last problem with the isosceles trapezoid. Ooh, didn't draw that one that well, but it is isosceles. Let's say this angle is 20, this angle is 60. Let's number these angles 1 and 2. Let's find angles 1 and 2. Well, a lot of ways to do this. One is, you have the parallel lines. You can think of the diagonal as a transversal. You get the letter Z. That means, whoops, angle 1 and angle 2. That's, what did I write? I want to find angle 1 and angle 2. 20 equals angle 2, because they are alternate interior angles. They make the Z. Well, if this angle over here is 60, we know 1 and 2 together also have to add up to 60 because it's an isosceles trapezoid. And if we know 2 is 40, we know angle 1, if 2 is 20, sorry, angle 1 has to be 40 because together they have to add up to 60. Okay? An isosceles trapezoid, what makes it different? Congruent legs, congruent base angles, congruent diagonals.